Greetings to all the viewers. The session is going to cover the intermediate chemistry. We'll be fetching for your international entrance and competitive exams as well. India is conducting JEE Advanced and JEE Mains examination all across India for the entrance into IIT and NIT stream. NEET exam will be conducted to get the entrance into medical stream. In addition to all these, Telangana and Andhra Pradesh government are conducting the entrance examination into a BTech stream by conducting MCET exam. Government organizations are conducting competitive exams for the admission into the various government organized jobs, so that competitive exam general studies question paper will be there, general science content will be the common paper available over there. The session we are covering is fetching for that kind of preparation. Here the first question covering with the Nobel Prize in the field of chemistry. The Royal Swedish Academy of the Sciences has decided to award 1996 Nobel Prize in the chemistry to the Professor Robert F. Cole, Jr., Rice University, Houston, United States of America. Professor Sir Harold Kroto, University of Sussex, Brighton, United Kingdom. Professor Richard E. Smalley, Rice University, Houston, United States of America. For their discovery of fullerenes, this kind of work was accorded. The discovery of carbon atoms bound in the form of balls is rewarded. New form of the element carbon called fullerenes, in which atoms are arranged in a closed shell, was discovered in 1985. Robert Cole and Harold Kroto, Richard E. Smalley together invented the process and the kind of material into this field of chemistry called fullerenes. The number of carbon atom shell can vary, and for this reason, numerous new carbon structures have been known. Formerly, six crystalline forms are known in the field of chemistry, in the field of carbon allotropy. Two kind of graphites and two kinds of diamonds, coyote and carbon-6 will be there. The coyote and carbon-6 are introduced in the year 1968 and 1972. From the year 1985, the new domain got introduced into the chemistry called fullerene chemistry. Fullerenes are formed when vaporized carbon condenses in the atmosphere inert gases. The gaseous carbon is obtained by directing intense pulse of laser light in the carbon surface. Fullerenes are the closed shell models where carbon got vaporized, and vaporized carbon can be aggregated in such a manner so that a laser light is induced upon, so carbon on the surface in the presence of inert atmosphere, so that the atoms are going to combine to form the cluster type of molecules. Few hundreds of atoms are going to arrange in such a manner. The entire gaseous skeleton is now supposed to be introduced into the vacuum chamber, where the cooling process got carried just above the absolute zero temperature. The carbon cluster can then analyzed with the mass spectroscopy. Mass spectroscopy is used to analyze the compound of fullerene, whichever generated by this method. Carl Kroto and Smalley performed this experiment together with the in the year 1985. By fine-tuning the experiment, they were able to particular to produce cluster of 60 carbon atoms and 70. 60 carbon atoms are more abundant in nature with the greater symmetry in nature, and they are accorded with the geometry truncated icosahedron. The polyhedron is accompanied by this 20 hexagonal and 12 pentagonal surfaces are available, and the pattern of European football has exactly the structure does geodetic dome designed by the American architect Buckminster. So that this is also called as Buckminster fullerene. For the year 1967 Montreal World Exhibition, the researchers named the newly discovered structure Buckminster fullerene after him. Nowadays, we can treat it, we can call it as a Buckminster fullerene because of the architecture of the scientist Buckminster Fuller. Right. The discovery of the unique structure of carbon-60 was published in the journal Nature and had a mixed reception, both criticism and enthusiastic acceptance. No physicist or chemist had expected carbon would be found in such a symmetrical form other than those already known. Okay, that extent symmetry, that extent stability we got in this carbon-60. Continuing their work in the year 1985 and 90, Cole, Kroto, and Smalley obtained a further evidence that structure ought to be correct. Among other things, they succeeded in identifying carbon clusters enclosed one or more metal atoms. These carbon halo such as shell molecules are taken in that metal atoms also imbibed, so that a new kind of variety of new molecules are introduced over. In the year 1990, physicist Krafthammer and D.R. Hoffman for the first time produced iso-label quantities of C60. So iso-label quantities also generated for the C60 by causing arc between the two graphite rods to burn in the presence of helium atmosphere and extracting the carbon condensate so formed using organic solvent. They obtained the mixture of carbon-60 and carbon-70, the structures of which could be determined. This confined correctness of the carbon-60 hypothesis. So this is a kind of another new methodology they developed in order to synthesize carbon-60 and carbon-70. The way was thus open for studying the chemical properties of C60 and the carbon clusters 70, 76, 78, and 84. New substances were produced from these compounds with the new unexpected properties. An entirely new branch of chemistry developed with the consequence of the areas astrochemistry, superconductivity, and the material chemistry and physics as well. So this is the way a new perception, new conception got introduced into the field of chemistry, that is Fullerene chemistry, which paved the way to introduce a bunch of auxiliaries, bunch of molecules with the new metal imbibation and that shallow molecule number of carbons, and also that geometry entire. By changing these kind of modifications and advancements, these compound find the multi-dimensional applications in the various fields. This is the way that Fullerene chemistry was accorded with the Nobel Prize together for these three scientists for the year 1996 in the field of chemistry. By this, we can conclude question 1. Go with the question number. These are the kind of chemical description geometry where the hexagonal and pentagonal rings are used to form a cage type of structure, which able to give the soccer ball type of material, where C60 is available, and in addition C72, 76, 84, 84, 84 of in either geometry. You can notice C96, C96, and C96. These many kind of Fullerene molecules are also obtained. Go with the question number 2, which is collected from the Cambridge Assessment International Education. Calcium oxide is lime. Give one use of lime. So calcium oxide is also called as a lime itself, and it finds multiple applications of them. We need to post only one application over here. The reaction of hydrochloric acid with the calcium oxide is said to be exothermic. State the meaning of term exothermic. What is meant by exothermic? We have to go with the definition over here. And the energy level diagram for the reaction hydrochloric acid with the calcium oxide is shown here. So here hydrochloric acid and calcium oxide supposed to be mixed over, and the products are generated, that is calcium chloride and water. During this reaction, reactants are mentioned at the topmost region. After the completion, the products are expected to have the lower energy like this during the progress of the reaction, which is plotted again is the energy, so that the products are obtained at the lower level of energy. By this, how can we justify the reaction is said to be exothermic? So we have to answer these questions whichever posed here. And first of all, we can go with the application of calcium oxide. Calcium oxide is also said to be a quicklime, and whose specifications are like this: 1 to 2 millimeters or 2 to 4 millimeters, and this extent of diameter dimensions are available. And here it exists in a white color, and it's available in the packaging of 25 kilograms usage. So when you go with the application of this calcium oxide used in the water treatment, softening of water, we can apply refractory soil improvement and metallurgy. During the metallurgical process and refractory soil improvement, for the improvement of soil, if the soil is acidic in nature, in order to neutralize that one, we need to mix up with the calcium oxide. And even in the water treatment, lime soda process is the ancient one where we can apply the lime that is coming from this calcium oxide itself. This is the way we can go with the applications of calcium oxide, and let's answer the question number 2, exothermic in nature. Exothermic reaction is said to be any reaction upon reacting all the reactants and getting rise the product. During the product formation, large extent of heat is evolved outside of the reaction. So arrow is indicating outward. This indicates heat is evolving. Evolving release of the heat is said to be a exothermic reaction. So in the form of heat is evolving over there. If heat is consuming is called endothermic in nature. This is the way reaction is exothermic reactions are mentioned. Let's go with this graph. How can we justify how this graph is used to give the product is a kind of exothermic reaction. This is a reaction where calcium oxide is going to combine with the hydrochloric acid, and salt and water are generated in this. So whenever reaction is proceeded, reactants are mentioned at the higher level in comparison to the product, so that reactants of higher energy, product is of lower energy, so that the difference energy will be released, so that we can say a release of energy is called exothermic in nature. This is the way product is obtained from this graph is exothermic in nature in thermal condition, right? So whatever questions mentioned over, we got successfully answered all the things, and let's go with the question number 3. Question number 3 collected from 2015 JEE Advanced Question Paper, Paper 1 conducted by the National Testing Agency. If the freezing point of 0.01 molar aqueous solution of this cobalt-3 chloride ammonia complex, which behaves as a strong electrolyte, at a negative 0.0558 degree centigrade, the number of chlorides in the coordination sphere of the complex KF of the water is 1.86 kilogram per mole inverse. So it is a kind of Kelvin, being it is a KF value. So that 1.86 Kelvin kilogram mole inverse is given. So freezing point of 0.01 molar aqueous solution of cobalt chloride ammonia complex was given. The number of chloride ions coordination sphere complexes, number of chloride ions to be answered, that to be identified. In order to answer that one, attempt this question by using concept of colligative properties. Colligative properties, the concept belongs to, and depression in the freezing point. Freezing point depression is the colligative property of the solution proportional to molality of the solute. Okay, molality is the kind of concentration term of the molality of the solute added to the solvent. So it purely depends upon molality of the solvent. So depression in the freezing point to be identified. The formula required is that delta TF is equal to I multiplied with KF multiplied with M. It is the product of I, KF and M. Delta TF denotes depression in the freezing point. I is called Van der factor. KF is called a cryoscopic constant. KF is called cryoscopic constant. M is called molality. Molality is measured. Number of moles present in the 1 kilogram of the solvent is called molality. So if solvent taken in the weight, grams, so that we can go with molality. Molality deals with the volume. Molality deals with the grams. Okay. So here delta TF is equal to I KF M is the formula for the calculation of depression in the freezing point. KF value is provided. KF denotes what? Cryoscopic constant, that is 1.86 Kelvin kilogram mole inverse, and molality of the solution is given by 0.01. TF of the solution. This is called the freezing point temperature of the solution, that is negative 0.0558 degree centigrade. And if solution value is there, then we can go with the solvent TF. Freezing temperature of the pure solvent is accorded with the 0 degree centigrade. Then delta TF, that is depression in the freezing point, is equal to pure solvent minus solution freezing temperature to be taken. The difference between the solvent and solution freezing temperatures is nothing but depression in the freezing point. So here pure solvent is given as 0 degrees, and solution is given by negative 0.0558 degrees centigrade. Negative multiplied get positive. So that delta TF is equal to 0.0558 Kelvin. This is depression in the freezing point. So whenever the value delta TF is known to you, we can substitute in this formula. So whenever we are going to substitute here, Vanta factor I is equal to delta TF by KF into M can be taken. 0.0558 K will be taken. This is solution freezing point temperature. Sorry. Just we calculated the value, sorry for that. 0.0558 Kelvin is the depression in the freezing point temperature that we calculated. And Kf is 1.86, that is that value is given over. And molality value is also known 0.01. So that I, this is called Vanta factor, is calculated as 3. I is equal to a Vanta factor with the number of ions dissociated in the complex. Okay. So Vanta factor with the relation of ions dissociated in the complex alpha n plus 1 minus alpha can be taken. Since complex is strong electrolyte, therefore dissociation completely done, and the degree of dissociation alpha is taken as the 1. So for strong electrolyte, maximum extent of ionization is possible where degree of dissociation is given by 1. Therefore, I is equal to n, because alpha is equal to 1, right? So that 1 minus 1 will become 0. So here alpha into n is nothing but 1 into n. 1 into n, it will become I is equal to n. So whenever alpha is equal to 1, I, that is Vanta factor, is equal to n. Okay, so number of ions dissociated. How many ions are dissociating in this reaction? That are 3. 3 ions are dissociated. Possibilities for the cobalt chloride ammonia complex. Cobalt chloride ammonia complex. Here so many are provided. 4 options are provided. From this data we have to go with cobalt ammonium chloride. If it is dissolved in solution, it will not give any ions because all the ligands are existing inside the coordination sphere. The ions whichever laying inside the coordination sphere will not get ionized. So that the complex is not the kind of ionizable. Go with the option number 2, where you can find one of the chlorine is in ionizable sphere and remaining all the ligands in non-ionizable sphere. So that we can say it will give the number of ions are 2 and chloride ions are 1. So that one complex sphere ion will be there, and this will not be the desired product, because n is equal to how many ions we need to get? 3 ions to be there, 3 ions to be generated. But here we got only 2, so that we can't go with this. And then go with the option number C, where cobalt NH3 taken by Cl2. There is a possibility, because the entire complex is become monopositive and 2 chlorides are released, so that 2 chlorides are giving 2 ions. 2 plus 1, total 3 ions are possible. So number of ions released from this complex will be 3. N is equal to, sorry, n is equal to 3, we got it. So n is equal to 3 is required for this complex. So this is expected to be the correct answer for this. If you go with option D, where you can find this complex positive ion in either 3 chloride ions. Total possible ions are 4. 4 ions are not mapping with n is equal to 3, so that we can cancel out option D. So from all the given possible options, only the provision is 2 chlorides ionizable if present. Total possible number of ions are only 3, so that n is equal to 3. So this is the expected answer, that is option number C. This is the way we can answer this question. So the number of chloride ions in the coordination sphere of the complex is the number of chloride ions in the coordination sphere. Inside the coordination sphere, how many are there? Inside the coordination sphere, number of chloride ions, only 1 ion is there. So 1 ion is the correct answer for this question number 3. This is the way we can answer question 3, which is collected from solutions and colligative properties. This is the physical chemistry domain. Let's go with the another question. Question number 4, collected from JEE Advanced 2015. Paper 1 question conducted by the National Testing Agency. The major product of the following reaction. This is the one collected from the organic chemistry point of view, and even stereochemistry matters. The compound which is provided is a kind of amine and carboxylic acid. We can say alpha amino acid. This is the alpha amino acid was taken. So whenever this alpha amino acid is undergoing the reaction with NaNO2 and aqueous HCl at 0 degrees centigrade, this is called diazotization in the presence of acidic medium. The sodium nitrite and aqueous hydrochloric acid are added. So here, wherever NH2 is there, that will be diazotized. And the condition here provided will be the steric retention. We are not supposed to go with the inversion of the stereochemistry. Rather, we can retain that stereochemistry whatever possible. In order to get that one, first of all, we have to take this amino acid. Amino acid, if taken and treated with NaNO2 and HCl at extremely low temperature, this amino is converted into diazonium salt. Diazonium salt will be originated. Diazonium salt, whenever hydrolyzed, diazonium salt N triple bond N positive will be highly dispatchable, so that upon hydrolysis, that N2 is the best leaving group, heavier one, so that water will be added and OH will be generated with this steric retention. Whatever upper wedge bond is there, again here in the diazotization we got wedge bond, and even after hydrolysis we got the wedge bond, so that alpha hydroxy carboxylic acid as the final product with the steric retention, that is purely available, where you can notice with the same kind of chemical structure in the option number C. For question number 4, option C will be the correct answer. What we need to perform? First of all, diazotization. Subsequently, we need to go for hydrolysis, so that hydroxy NH2 finally transformed into a hydroxy, and you can notice that in the option number C. For question 4, option C will be the right answer. Let's go with the question number 5. This is collected from Telangana IMCET examination conducted in the year 2020. Which halide of the alkaline earth metal is covalent in nature and can be soluble in organic solvents such as ethanol? Right. So this is a kind of question collected from the inorganic chemistry. Moreover, we can go with the S block elements. Right. So here, second main group element, it will be సంయోజనీయ స్వభావం మరియు ఆర్గానిక్ ద్రావణి అయిన ఇథనాల్లో కరుగు స్వభావం కలిగిన క్షార మృత్తిక లోహ హాలైడ్ ఏది? Here, first of all, we have to go with what will be the solubility of the compounds. Which compounds are soluble in ethanol or else acetone or else any organic solvent, and which compounds are supposed to be soluble in water. So always organic compounds are susceptible to dissolve in organic solvents in more preferential way. Inorganic compounds are able to soluble in inorganic solvents. That is the factor we can go with. And one more thing we need to notice is that is about organic inorganic point of view. Let's go with ionic and covalent. Most of the ionic compounds are soluble in water. Non-ionic compounds, that means covalent compounds, are soluble in non-polar solvents like benzene, acetone, acetonitrile. These solvents are preferable for what we can say covalent compounds. If you go with this what we can say water most if the ionic nature is more, the compounds are more susceptible to dissolve in water. So this is the way solubility can be segregated. The thing is, though all the compounds are taken are inorganic in nature, but there is an exception. The compound is able to dissolve in ethanol. This is a kind of exceptional condition. We can say abnormal nature of the compound. Inorganic substances are supposed to be dissolved in inorganic solvents in the general trend. Here, one of the compound is soluble in ethanol, that is beryllium chloride. Why beryllium chloride is soluble? Why can't we dissolve strontium chloride, barium chloride, magnesium chloride, though all belongs to second main group, alkaline earth metals only? Let's explain with this electronegativity difference and the nature of the compound generated. Electronegativity of beryllium is mentioned as 1.57. Beryllium is of second main group element. That is the first element in that series, right? And electronegativity of the chlorine is accorded with the 3.16. According to the Mulliken scale, we can define their electronegativity values. Okay. The difference between the electronegativity, if you want to calculate the difference, so that 3.16 from this you can subtract 1.57. The difference is 1.59. This is electronegativity difference between the beryllium and the chlorine, right? Here is the condition. If any molecule is forming, if the electronegativity difference between the combining atoms is greater than 2.0, then the molecule is designated as an ionic substance. Below 2.0, if electronegativity difference is there, the molecule is said to be covalent in nature. In case of this beryllium chloride, the electronegativity difference is calculated as 1.59. So that we can obviously say it is the covalent compound. It is not ionic, right? So it is the covalent compound. So being it is covalent, obviously it will go with the organic solvent ethanol. So it will be soluble in ethanol. Right. So this is the way we can answer this question. For question 5, option 3 is the right answer. Let's move on to question number 6, last question of the session. An aqueous solution of the borax is borax jaladravanamo. What will be the nature we need to predict? Either neutral, amphoteric, basic, or acidic. What nature accorded for this borax solution we need to mention, so that the compound borax is given by Na2B4O7. As already we categorized that all the metal oxides are said to be basic, all non-metal oxides are said to be acidic, all metalloid oxides are said to be amphoteric in nature. Based on that assumption, it's the kind of both. You can notice the sodium is the metal, boron is the non-metal. So that we will after the hydrolysis we will get the mixture of products. Mixture of products are possible. One is sodium hydroxide, and another will be H3BO3. So whatever part oxygen binding with sodium, that is converted, that is coming out as a basic one. That is sodium hydroxide is strongly based. Most familiar, everybody know about that. Whatever oxygen binding with boron coming up as a acidic one, acidic part, H3BO3 is called a boric acid, which is weakly acidic in nature. So that whatever oxygen part binding with sodium is a basic in nature, binding with boron is a acidic in nature. But after getting mixture of these two products, here the nature of acid is mild, nature of base is strong. So that stronger base obviously dominates. So entire nature of this or aqueous borax solution will be basic in nature. This is the way we can answer this question. So that basic in nature, Ksharamo is the correct answer. Right. Let me explain one more time. Na2B4O7 is called borax. Upon addition of water, whatever part combining, oxygen part combining with sodium is coming out as a basic one, and boron oxygen combination part is coming as a acidic one. Right. So that after the hydrolysis, we will get a mixture of two products. One is acidic, another basic. But here sodium hydroxide is having high strength of basicity, and what we can say boric acid is having mild strength of acidity. So that in the overall comparison, the entire solution, aqueous borax solution, looks like a alkaline in nature because of higher strength of sodium hydroxide. This is the way we can answer. For question number 6, option 3 is the correct answer. By this, we are going to conclude the session. And hopefully this session is really informative for your preparation. Those who are aspiring for the various examinations, the kind of sessions are very much helpful. I'm sincerely requesting to like the channel. In order to comment, we have a question for the session. In order to comment, the question is, can you mention the examples related with the acidic oxides, basic oxides, and amphoteric oxides? 2 examples per each. You can post as comments in this session. Acidic oxides 2, basic oxides 2, amphoteric oxides 2. Any 2 examples of your wish can be posted in this comment box for the session. And you can share with us parents who are serious about the examinations, and subscribe the channel. Definitely we will go with a new content in the near future. Thank you one and all for your patient listening.